Hey y'all, let's cover lesson 4, prime factorization. So we're going to recall that in lesson 3, we talked about 3 times 4 is equal to 12. And the number 12 is the product, called the product, and 3 and 4 are called the factors. So 12 is called the product, and 3 or 4 are called the factors. When we do word problems later on, whenever it asks for you to find the product, that's going to be multiplication. You're going to multiply when you see that. Okay, remember, sum is addition, difference is subtraction, product is multiplication, and quotient is division. All right, so we've covered all of those. Find all whole number factors of 18. Well, 18 can be 1 times 18 is 18. If I divide 18 by 2, it's even, so I know I can do that. It's 2 times 9 is 18. Also 3 times 6. 3 times 6 is 18. So the whole number factors of 18 are 1. I'm just going to go in order. 1, 2, 3, 6, 9, and 18. 2, 3, 6, 9, and 18. Just to put them in order. Okay. All right. Let A and B be whole numbers. Then A is divisible by B if, okay, well, oh, this is a different one. Hold on, y'all. It's not. I don't have my glasses on. All right. The remainder, okay, if the remainder, so A and B be whole numbers, let A is divisible by B if the remainder when A is divided, the remainder when A is divided by B is 0. So no remainder. So if you divide it into a calculator, you do not get a decimal. You get a whole number, okay? So B is a divisor of A. In this case, we say that B is a divisor of A. B is a divisor of A. And just like 6 is a divisor of 18. Example, 6 is a divisor of 18. All right. Find all whole number divisors of 18. Okay, we already did this. Another way to think about it is, what two numbers can you multiply together to give you 18? It's the same thing. So in this case, it's how we can take 18 and break them up. So we've got the whole number factors of 18 are the same thing as the whole number divisors of 18. They are both the same. So 1, 2, 3, 6, 9, and 18. Okay. Let's talk about divisibility test. Now, one of the things that I find is folks don't know where to start. If you get a big number or a number that you don't know what divides into it, these are the little tests that you can do to find out. So let's go through that. If it's even numbers are divisible by 2. Even numbers are divisible by 2. So if it ends in a 0, 2, 4, 6, or 8, it's divisible by 2. So you could take that number and divide it by 2 to see what other number is a divisor. Okay. If it's divisibility by 3 is if the sum of the digits, so if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. And I'll show you what I mean. Okay. So if the sum of the digits, remember, sum is addition. If the sum, so remember this is adding, of the digits of a number, of the digits of a number, is divisible by 3, then the number is divisible by 3. This is a great little tool. Here's an example, 57. So you've got the number 57. Is that divisible by 3? I don't know. It's past 3 times 12, which is 36. So it's beyond my reach. So to find out, I just find the sum of the 2 digits. So 5, to do this, 5 plus 7, and that's 12. Wow, 12 is divisible by 3. So I'm going to put 12 is divisible by 3. So 57 is as well. Just another great tool in order to find the products. All right, divisibility by 4. If the last 2 digits, so if you're looking at a number and the last 2 digits are divisible by 4, if the last 2 digits are divisible by 4, then the number itself is divisible by 4. Then the number is divisible by 4. Like 1024. We'll use that as an example. Is 1024 divisible by 4? A lot. So in this case, they're telling us just to use the last 2 digits. And if they're divisible by 4, which it is, 24 divided by 4 is 6, then this number 1024 is divisible by 4. Okay. All right. So 24 is divisible by 4. 24 divisible by 4. Therefore, 1024 is divisible by 4. All right, divisibility by 5. So if the number ends in 0 or 5, period, the number is divisible by 5. So if the number ends in 0 or 5, the number is divisible by 5. Okay. So an example, let's take 1025. It ends in a 5, so it's divisible by 5. If I stuck a 0 on here, it too is divisible by 5 because it ends in 0 or 5. All right. Divisibility by 6. All right, so if a number is divisible, let me get you lined up here, by both 2 and 3. So if a number is divisible by both 2 and 3, it's divisible by 6. Because 2 times 3 is 6. So if they each factor in or divide into it, the number, then 6 itself will as well. All right, for divisibility by 9, if the sum of the digits of a number is divisible by 9. So just the same concept with the 3. Remember, we took the sum of the digits, the 57, they added up to 12. So because it was divisible by 3, the 12 was, then the 57 was as well. Well, in this case, we're going to do the same concept, but it has to be divisible by 9. So if the sum of the digits of a number is divisible by 9, it's sum of the digits of a number is divisible by 9, then the number is divisible by 9. Then the number is divisible by 9. All right. A whole number other than 1, because 1 is a prime number. A whole number other than 1 is a prime number if it only has 2 factors, 1 and itself. Prime number if it only has 2 factors, itself and 1. Okay, so 2 only has the factors of 2 times 1. 3 only has the factors of 2 times 1. 5, 7, 11, 13, 15, 17, 19. There's so many. So which of the whole numbers are prime? Well, we know 15 is not. 5 plus 1 is 6, and 6 is divisible by 3. So that's not prime. We'll look at 23. 23 is 2 plus 3 would be 5. That's not going to be divisible by 3 or 9. No zeros, no 5s. Gosh, no 4s, no 6s. Well, 23 is prime. Okay, let's see if we can prove this. 15, not prime, because 15 can be 3 times 5. Let's look at 23. 23 is prime because its only factors are 1 times 23. 51, 5 plus 1 is 6, and that's divisible by 3. So I know that's not prime. I knew it wasn't even because it doesn't end in a 0, 2, 4, 6, or 8. And I knew it wasn't divisible by 5. There's no 0 or 5. So I always start from, once I hit my zeros, my 1s, my 2s, my 5s, then I go to my 3s. And 51 is not prime because I can multiply 3 times 17. And that's 51. 15, 23, 51. And then 59, well, it's prime. It only has 1 times 59. All right, list all the prime numbers less than 30. Okay, so we've got, well, 1, but that's a given. So let's go with 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Those are all the prime numbers less than 30. Okay, a composite number is a whole number. It's not prime. It's a whole number that is not prime. It has factors other than the value itself in 1. It's not prime. Has factors. It has factors other than itself in 1. Okay, so there's other numbers that will divide into it or multiply together to make up that number. So is the whole number 2,571 prime or composite? Well, it doesn't end in an even number, so it's not divisible by 2. It doesn't end in a 0 or 5. What else? My next thing is to go to the 3s. So I'm going to add these up. 2 plus 5 plus 7 plus 1. And that's equal to 15. 15 is divisible by 3. So this is divisible by 3, as is the 2,571. Because the sum of the digits add up to a number that's divisible by 3, and that's one of the rules. Okay, so it is composite. It is not prime. And the answer was composite. And then if you take 3 times 857, you get 2,571. Okay, that's the proof for it. All right. All right, fundamental theorem of arithmetic. Any composite number, it can't be prime. Any composite number can be expressed uniquely as a product of prime numbers. So a bunch of prime numbers multiplied together will provide you a composite number. Right? This product is called the prime factorization. Prime factorization. All right. And you write it as multiplication. Right, as multiplication. All right, we will use a factor tree to find the product. All right, express 36 as a product of prime factors. Pardon me. So we start with 36. And I need 2 numbers that multiply together besides 1 and 36 that make up 36. My first thing I'm going to think of is 6 times 6. Okay, 6 is not a prime number, so we can keep factoring this. Break them up. What 2 numbers multiply together to give us 6? 2 times 3. So this one has 2 times 3 as well. These are all prime numbers. So the prime factors for 36 are 2 times 2 times 3 times 3. Take it as low as you can go. And it needs to end up being one of the prime factors that are going to be less than 30. Okay, for the most part, unless you, well, I can't say that. Because for the prime number, when you do the prime factorization, all the numbers that multiply together to make up that number, it have to be prime. So I can't say that they're all going to be less than 30 because it could be 57 or something like that. And it wouldn't be 57 because that's not prime. All right, let's go to 54. 54, we're going to make our tree again. Let's break it up into 2. My first things are 9 times 6. That's what I would think about for that. Now, I knew it was divisible by 9 because 5 plus 4 is 9. And 9 is divisible by 9, it makes 1. The other thing to think about is I knew my multiplication tables. So I knew 9 times 6 was 54. What if you don't? What if you don't know your multiplication tables? Then the first thing you're going to see here is, oh, this is divisible by 2. Okay, so maybe that's the way I should go with this instead. All right, I'm going to go to the way that, I'm trying to think like what you would have to do. 54, you don't know your multiplication tables. I hope you do. If you don't, that's going to be something you really need to work towards. It's only going to benefit you the rest of your life. So 54 would be 2 times 27. Right, 2 times 27. All right, now 27 is not prime. So 2 is. So we're done with the 2. So 54 equals, I know 2 is going to be one of them. I'm going to factor this one. 2 doesn't go into it. 5 doesn't go into it. 2 plus 7 is 9. So 9 goes into it. 9 times 3. Okay, 3 is prime. And then we've got the 9 is 3 times 3. So times 3 times 3. That's my prime factorization for 54. Okay, the expression a to the m means, well, it means a m times. A times a times a dot 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 times a. But we want to do it m times. It's based on what that exponent is, what the number in the top right means. So say we have 3 to the 4th. That just means we need 3 times itself 4 times. 3 times 3 times 3 times 3. Right. The number A is called the base. It's the base of the exponential expression. And the number M is called the exponent. The exponent M tells us to repeat the base A, as a factor M times. So you want to take whatever that A to the M is, whatever that M is, you're going to go A times A times A, M times, however many times that is. So let's do 3 more. Let's do 2 to the 5th. So the base is 2, and the exponent's 5. So that's 2 to the 5th is equal to 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. And then this 2 times 2 is 4 times 2. 4 times 4 is 16 times 2. And 16 times 2 is 32. All right. Let's go with 3 cubed. That's equal to 3 times 3 times 3. So 3 times 3 is 9. Bring this 3 down. 9 times 3 is 27. And the last one we have here is 5 squared. 5 times 5, and that is 25. Pardon me. Okay. When you're putting this into your calculator, I'm not sure which type you're using. You might be using your phone. There are different keys that can be used based on the calculator that you're using. So say you have a TI-30X2S, or you could have what we call a caret. So you would go, a 3 cubed would be 3 caret 3 equals. If you don't have the caret, the little hoo-hoo, then you might have x to the y, y to the x, or x to the box. You might have one of those. That's going to replace whenever I say the words caret. That is going to be your exponent key. If it's none of those, please feel free to shoot me a picture of your calculator, and I'll help you find it. Or you can just Google, hey, where is the exponent key for, and then put in your model for your calculator. So say TI-30XA, which has x to the box, TI-30X2S, which has the caret. All of the graphing calculators for your TI have the caret. It's just above the division symbol. All right. You do not need a graphing calculator at all. At all. Please don't buy one. All right, express the solutions to the prime factorizations above in compact form using exponents. Okay, so what do we want to do here? We're doing these two. We're going to do 36 and we're going to do 54. So 36, we've got our prime factorizations up here. 36 is 2 times 2 times 3 times 3. So it's 2 times 2 times 3 times 3. So we're going to put that in a compact form of prime factorization, but using the exponents. So 36 is equal to, well, there's 2 2's. So that's 2 squared. And there's 2 3's. So that's times 3 squared. There's 2 3's and 2 2's. The other one was 54. And 54 was 2 times 3 times 3 times 3. All right, so 54, in the same manner, there's only 1 2, so I'm just going to put 2. I do not need to put a 1 up above with the 2 because it's already represented, the 2. There's already an assumed 1. You never put 1 in the exponent. It's always a given. Now the 3's, we have 3 3's, so those have to be represented. Okay. All right, evaluate the expression 2 cubed times 3 squared times 5 squared. Okay, so 2 cubed times 3 squared times 5 squared. Well, there's 2 times 2 times 2 times 3 times 3, because there's 2 of those, times 5 times 5. Okay, well, 2 times 2 times 2 is 8. 8 times 9, and then 5 squared is 25. There's another way to do this, which is your calculator, because this is going to get nasty. This is going to be 72 times 25, and I'm going to have to do some calculating here. Or we could use our calculators and at this point, or you can go 2 caret 3 times 3 caret 2 times 5 caret 2 equals. And that should give you, I believe it's 1800. Let me double check this. I don't have my calculator with me. 7, 10, 25, 36, 4, 14, 0, 10. Yep, 1800. So 1800 should be your answer for this one. Okay. I'm just going 72 times 25. Please notice that I did leave my blank here for the tens, the ones placed that on that. All right, next, and I believe the last page for lesson 2. Sorry, lesson 4. All right, we're going to let S represent the length of each side of a square. Let area A as the square is given by area. Remember, it's always measured in squares. Is side times side. All right, length times width, but they're both S's. So side times side is area. What we could say here is area is side squared. Okay, that's not 5, that's the letter S for side. S equals side. It's also represented here. So here's an example. The edge of a square is 15 meters. Find the area of the square. Well, the area of the square is 15 meters. I'm sorry, the edge of a square. So that's 15 squared, because area is side squared. So all you're going to do in your calculator is 15 caret 2 equals. Okay, and you should get 225. So area is equal to 225. Here's an issue. You've been given a question. If you just tell me that A is equal to 225, that is not representing an answer to the question. Whenever you're given a question like this, anything that's not just numbers, if it's any kind of words involved, you need to give me a sentence for the answer. So in regards to this, I'm talking about the area of the square. The area is, you need to give me a sentence. The area is 225, but 225 what? Sit-ups, push-ups, what are we doing here? It's square meters. Because we're squaring it, and we need to know the unit is meters, and they are being squared. Or you could say square meters. So you could say meters squared, you could say 225 meters squared, you could say 225 square meters. I thought I got rid of that. All right, that is that's it for lesson 4. I'll see you on lesson 5. Have a great day. Let me know if you have any questions.